So today we'll be talking about ultrasonic sensors. So why are these sensors called ultrasonic sensors? They are called ultrasonic sensors because they utilize sounds above our hearing range, usually between 23 and 40 kilohertz. Emitting an ultrasonic chip, the sensor measures the amount of time it takes for the sound to travel to an object, bounce off it, and return to the sensor. It is essentially echolocation, much like a bat. We know that the speed of sound in air at room temperature is 343 meters per second. So we simply have to calculate how long it takes for an echo to bounce off an object, multiply it by 343 and divide it by 2 in order to know how far away something is in meters. This may seem like an easy concept, and indeed, it is actually quite straightforward. Now, how does an ultrasonic sensor work? Ultrasonic sensors is made up of two parts: a transmitter and a receiver located as closely together as reasonably possible. The transmitter sends out the chip, while the receiver dictates the chip or the sound. There also needs to be some sort of logic device that generates the chip, detects the chip, and times the echo. Sometimes, though, a transmitter and receiver can be combined in a single unit to save space, which is called an ultrasonic transceiver. There are some real life considerations to think about with an ultrasonic sensor. First, when the noise comes out of the transmitter, it doesn't leave straight like a laser, but spreads out in a cone shape. The size of this cone is dependent on the beam angle, and it varies between sensors. In general, a narrow beam angle is more selective and has a longer range, while a wide beam spreads the energy into a wider arc. Being such a mature technology, not only is it reliable, but the benefits and drawbacks of ultrasonic sensors are well documented. They are unaffected by color and lighting, making them work extremely well in varying light conditions or with translucent or transparent objects, such as water or glass. They are relatively precise with a typical precision of about 1%, though more precision can be achieved with both special sensors and a controlled environment. Taking into account beam spread, ultrasonic sensor minimum and maximum ranges are surprisingly wide, with most sensors able to detect as near as a few centimeters up to around 5 meters, though there are models that can go up to 18 meters. Even at that maximum range, the time it takes the acoustic pulse to travel to the target and back is quick enough that the refresh rates of ultrasonic sensors are fast enough for most purposes. Finally, ultrasonic sensors are resistant to both electrically and acoustically noisy environments, particularly when using modules that encode the chips. Like everything, there are trade-offs here as well. The speed of sound is dependent on temperature and humidity, so environmental conditions may change the precision of the measurements. However, this tends to be inconsequential in all but the harshest of environments or with the strictest of demands on precision. And even though the detection zone is three-dimensional, an ultrasonic sensor only detects that there is an object a certain distance from the detector and cannot provide feedback on where the object is in the sensing area, nor any feature such as shape or color. And why these sensors are relatively small for industrial or automotive applications, you can see that they will be too big for very small embedded projects. And And while this may not affect most of us, these do need a minimum for the chip to pass through, so they do not work in a vacuum. With these considerations in mind, it's easy to see that ultrasonic sensors will still be the ideal solution for a large variety of applications. They remain a staple in modern industrial application and liquid level sensing, but are becoming more and more common on vehicles as well. Even robots are rarely seen without an ultrasonic sensor anymore. Unlike other technologies that seem to come and go, the demand for ultrasonic sensors continues to climb with no end in sight. Okay, this is much we can take on ultrasonic sensors. So you can like and share and subscribe to the channel in order to see more of these videos. So we've discussed the letter U in our A to Z instrumentation challenge. What's the next letter? Yes. So let's take that. Now we've talked about the letter U in our A to Z instrumentation challenge. So we're going over to the letter V. So guess what the device or instrument will be in the comment section as I see you in the next video.